I see people are starting to come in. Good morning, everyone, and welcome to this fourth Fair Ease technical webinar on RO Crate. While we're waiting for more people to come in, I'll just give a very brief intro, and then I'll pass on to our speakers. So, firstly, this webinar is the fourth of our series. As we know, scientific collaboration is important, especially in a world where societal and scientific challenges are intertwined. And this is the case, especially in our field of earth and environmental sciences. So it has become essential to develop gateways for developing services that span disciplines. And this is the focus of our EU-funded project, Fair Ease. Specifically, we will go beyond the state of the art to customize and operate distributed and integrated services for observation and modeling of the Earth system, environment, and biodiversity. Previously, we've already introduced the project in past webinars. We've also explored our data lake, and we discussed how to harness oceanographic data using Galaxy Europe. Now, we're excited to delve into RO-Crate in another engaging webinar. And in this session, we will demonstrate how RO-Crate can transform your approach to research data management by making your data more fair. So today, we'll hear an introduction, key features, and benefits of RO-Crate from Stian Soiland-Reyes from the University of Manchester in the UK. This will be followed by a general introduction on interoperability, the work done in Fair Impact, and joining us from the project is Esteban Gonzalez from the Universidad Politécnica de Madrid, followed by practical use cases and examples of RO-Crate in action. So we'll hear from Marie-Josse from Ifremer on workflows in Galaxy, followed by Marc Portier from Villers, Belgium. We'll talk about data management use case. Finally, at the end, we have a Q&A and panel session where you can interact with our speakers. And I will be joined in moderating this by Gael, Lymer. Now, just to give you a few reminders, so do write in the chat just to say hello. We'd like to hear where you're connecting from and also just to test and everything's okay. Also, just a reminder, so we are in a meeting setup. Please mute your microphone and switch off your camera and only speak when you're provided permission to by the host, myself, or Gael later on. Just a reminder as well that this is a recorded webinar. So the slides and the recording will be published online on the event page within 1 week of this broadcast. Please do keep your questions until the end of each presentation at least, or ideally during the Q&A and panel session, just in case your question is addressed in later slides. Also, if you like our webinar, do share your impressions and screenshots. If you'd like, you can tag us on our channels, as you can see there on X or in LinkedIn. So I think we have quite a few people who have joined us now, so I think we can start. Stian, are you ready? May I pass the floor to you now?
Yeah, go on.
Okay, very well. So Stian, take it away.
All right, so I'll talk to you about RO-Crate. Now, just to clarify, although I have the lovely mounts in the back, I'm not actually part of the Fair East project. So I added all the other locals in here, which many of them, as you see, are also in EOSC. So I'm from the University of Manchester. And I'll talk to you a bit about RO-Crate. So where we're coming from is we started in Manchester some 10 years ago or so, making up the concept of the research update. Now, the main idea here is to change how we do publishing of scientific or scholarly outputs to have not just a PDF of text, but to bring in all those digital assets that we had while making the research. There could be data, could be workflows, could be scripts, and so on. Put them in a package and connect them to each other. That's the main idea of the research update. But how do you write down these connections? So that's will be our next slide, where we talk about what requirements do we have for doing a fair research update. So we want to do these descriptions of all the individual items of the research object, and in such a way that the metadata can move along with the data, right? So that you don't detach it, it will be neighboring the data. But we want some kind of platform independence, so we don't want to build yet another repository which limits how everything should be, but have some kind of exchange mechanism that is more flexible to move across the different services. I've always been part of research of it, the idea of reproducibility. So this is why we wanted software, if you have used software, for that to be part of it, and there might be additional requirements for including software in a package like this. But there might be things you can't include. It could be sensitive or very large data. And in this case, you need identifiers for them and say, how do I apply for access somewhere else? And obviously, we want to promote the FAIR principles. And a main thing of that is to propagate these kind of identifiers and also citations. And the research library will be the vessel for these kind of things. So if we move to the next slide, we see how we actually implemented this now with our crates. This is just a visual implementation. There will be some lovely JSON coming up later from the other presenters. But basically, that's how it is. The simplest research of it is one file, and I'm saying, can I make this folder into research update? Yes, but adding the magic file, our crate metadata. And in there, you describe that file, but also what is the research update about. Now you have multiple files, you can describe each of them separately. Then it might be you don't have any files, you're talking about things on the internet, it could be a more complex subject, they all fit within this description. So you can mix and match between real deposits, that downloadable things, or things that are out there somewhere else. And in fact, there's a distinction we call now between attached RQA, which is like this, folder-based, or detached one, which is just on the web. But you can be anywhere along the slide of that scale. So you see the identifiers keep popping up here, and this is obviously because we are building on something called JSON LD. The LD stands for link data. So if you heard about that, the idea is the identifiers can be connected across multiple instances. So if you use the same identifiers for the person as me, the ORCID identifier will be the good one. You can merge these together using knowledge graph technologies and so on. But in our crate, if you do the next slide, we kind of try to hide a bit about all this knowledge graph thing. We are using that technology, but we're kind of trying to make it a bit more developer friendly by just talking about JSON. An important part I want to add about FAIR is to not just think about the machines all the time. We want to make everything machine readable, but keep the humans in the loop. You gathered all this lovely metadata. Can you now render it also for them to see it? So here you see an example of where that JSON has been turned back into a web page. And in fact, we encourage that static page to be stored next to the JSON so that someone who don't speak JSON natively can also see all the metadata you have gathered. So if you click a little button now for the next, you will see a bit more real one. There you go. So this is from a ByCovid project. And if you click again, here is how it would work in the browser. You would click into each of these elements of the research object, and then you could expand the attributes of that as well. And so you get this graph, but expanded into different web pages, but reality is just one HTML file. Okay, so move on to the next slide. The way we've done this is we used existing technologies. We not really invented anything new. We just put them into a system on how to do it. So although it says specification, is more like a kind of guidance for how to do this with example-driven JSON. So you see in the menu there the different kind of objects you could be adding to your research object. The main distinction is the data entities, which are some kind of file-like thing, or the contextual entity, things in the world we want to describe. It could be location, could be animals, could be all kind of things. Depends on your science what that exactly is. And of course, we have some provenance or workflows in there as well. If you have those, they can come along on the journey. So this developed as a community project. So although you can't even see all the authors here because it's like a whole page long and several of them are in this call right now. So hello, thank you everyone. So if you go to the next slide, I want to talk a bit about how our crate have been used, but I can't go through all of them. So you can go to our web pages to see many more. So you see that they're hardly readable here to get them all squeezed in. These are just the ones we have documented, but I'll touch a bit upon those that I think are relevant to the earth sciences. So if we go to the next slide, we have this one. You think, well, language data, what's that got to do with earth sciences? Well, you see it in the middle there. So this is the Australian partners of me, Peter Sefton, who we are both co-chairing this community. He's coming more from cultural heritage perspective and particularly working with endangered languages in the Australia and Pacific region. And so they're gathering lots of samples of recordings and these kind of things, and obviously lots of metadata associated with that, translations and so on. But that's why I pasted some evil JSON in the middle. Geography is part of it, right? Because where's the language spoken? So here you see how they are using, for instance, some complex polygon methods, which is an extension for FireCrate for how to do this a bit more geographical areas using GeoSparkle, I think it is. Anyway, that was the only JSON I have on my slides, I think. So next page, we see a bit more. And here, I think this is slightly outdated, so please feel free to correct me now, Julian, because this is about the Reliance project, which you probably have heard about, which use something called Our Hub. So this is a place where you could deposit our crates. Now, I said we're platform independent, but still is very useful to have something like the Our Hub where you can put and store your Our crates. Now, if you are using the extension storage crate for Earth observation data, it can do things like you see showing spatial coverage and things like that as well. And similar for notebooks and things like that. There's additional support for that in the Arbor Hub. It's also a way to make research object without you typing any JSONs in there. Now, as far as I understand, some of the work from the Reliance project will continue in the Fair to Adapt project, which I'm not involved with, so I'm not going to say anything more about that, but it's ongoing work continuing here. You see here, the kind of coverage is extending a lot because also the time and the height and so on comes into play. So they have the concept of data cubes to say which particular slice of space-time is it you're talking about. Okay, so if we go to the next slide, we will talk about a new project that I'm in called Climate Adapt. So what Fair to Adapt and Climate Adapt, we're all adapting, is part of a new Call of Years project. Now in this one, we're going a bit more techy. We are looking at how, similar to what you talk about, but the data lakes and the other webinars, but how can we move this forward, particularly thinking about the legal aspects and when you have basically interoperability, because you have data sources that may not directly connect to each other semantically. They might have to be integrated in different ways, or there could be legal reasons, licenses, and so on, restrictions of use. Here, the our crate becomes a metadata vessel because we have done transformation of the data, and particularly the metadata, into a common store, and then our crate will move the transform data along with all the original identifiers and so on. Obviously, we have all the attributions and licenses, which could become a bit messy when having many different sources. Our crates allow you to tag on many of these, rather than just saying there's one license for my output, there's different ones for different files, right? And also here it is the opposite side as well, the evidence store. So we talk a lot about provenance often, so it's like, or to support scientific process and so on. But think about the people who are making data available, particularly from trusted research environments and so on. They want to be concerned that data is not abused and is only used in a certain context as it is expressed by its license. So here we have an evidence store as well about how data have been used. And again, it's using our crate. In this case, again, it would be mainly by references to this, because if we're talking about, I did this and I got some data out, I'm not going to give you that data, I'm just going to describe the data for you. So that would be forming a data usage register. We don't know the logo for Climate Adapt yet, so I just put all of them up there. So you can see there. Okay, so next slide, I think, is the last one. Yeah, so this is going back into workflow. Now, I come from a workflow background, so been doing computational workflows for quite a while. So that's kind of always been in the background for research object as well, although now it's definitely not a requirement for using something like our crate, but there is, as I said, a big slot for it, and we host the Workflow Hub, which you will hear more about later. And here we are using our crate as a kind of currency of exchange. So you see the whole ecosystem, Life Monitor doing testing, Workflow Hub having a registry of workflows, loading up workflows from GitHub where they're described with our crate. Galaxy then downloads this. So they're all talking our crates to each other, but they kind of each just look for their little thing they care about in the description and then just let everything else just move along. And I think that's an important principle. So you're not like throwing away metadata at every instance, but you can allow the metadata to move forward. And so you're not closing doors whenever you're doing an integration. Okay, so I think that's all from me. So if you do, yeah, so one more thing. how do we describe this thing? Because I talked about slightly different kinds of arrow crates. Now that's something we call arrow crate profiles. And it's somewhat loose term about what does actually mean to be a profile. It's a bit less strict than you might think from programming language. We call it a kind of duck typing. If it talks like a duck and quacks like a duck, it's probably a duck. And basically, if you have lots of arrow crates that look the same, they're essentially following a profile, right? So all the workflows in Workflow Hub, for instance, they are workflow arrow crates. They require a workflow as part of it. They may have other things which the hub doesn't care about. Then you have extensions to profiles even. So workflow one arrow crate, which we'll hear more about later. We'll talk about an execution of such a workflow. So now, of course, the data will come in as well. And then it might even be in a sensitive environment. So with the 5 safe crates in the bottom where you add in the human aspect of who allowed this workflow to run, what is the project approval for this and this access to the sensitive data. That's also kind of provenance that is not directly related to data, but that's the kind of thing we're also bringing up in the Climate Adapt project. So you see here how different kind of fragments of the arrow crate can be formalized in these profiles. And we're now building registries, and Marc could talk more about that if we had time, and also validators for these kind of different profiles, so that you can know you're following what a particular registry is expecting. So that's it from me.
Thank you.
Oh, there's one about tutorials. So obviously we have tutorials, so you can go there and look. This could be a bit more slower pace than what I just gave you here. There's the sandbox, which is very nice, where you can type in JSON, or you can click on through an interactive editor to make arrow crates. And of course, there's a Python library. So just a few tastes of the kind of tooling, because that's the second aspect that we want to have joint tooling for these things. That's it, I promise.
Thank you very much, Stian, for that comprehensive overview on arrow crate. Next, we have Esteban Gonzalez Guardia, who will talk about a general introduction on interoperability work done in Fair Impact. So, Esteban?
Yeah, thank you, Rob. So today we are going to talk about the interoperability. Okay, interoperability, we can say, is the hidden children of the FAIR principles. Okay, everybody is very unknown. Everybody knows about PIDs or licenses, but it's more tricky, the part of the interoperability. Okay, I'm going to show you some of the work that we did in FAIR Impact together in collaboration with Reliance. Remember that the Reliance project was deployed a research objects repository where you can manage the life cycle of the research object in the environmental domain. Okay, so we will we will see the relation between this interoperability, research object, and arrow crate. Okay, I just put the definition of Wikipedia because I really like it. Okay, so interoperability is the capacity of interaction between IT systems. Okay, so when we talk about IT system, we try to avoid the human intervention. Okay, so we are it is much related with the machine readable. Okay? And also to interact these IT systems, for sure, we need to fully understand the interfaces of these systems. Okay, so this is about interoperability. Interoperability is focused right now more in the part of the data. It's basically data integration with another data. We can find, for example, an example of OpenAir. No? OpenAir is an aggregator of metadata. So basically, you have different data providers that harvesting information to the OpenAir. Okay, and in this case, OpenAir can harvest this information because they follow always the same protocol and the same specifications. Okay, so basically they speak a common language. So you can find here the different principles about interoperability. Okay, so basically you can see that you have to use for sure a common language representation. You have to follow the vocabularies that follow the FAIR principles. Doesn't make sense you use a vocabulary that only you know for sure. Remember that this interaction, we need to fully understand what are these interfaces, what is the specification what we use. Okay, it's basically an agreement. And also there is another principle related with interoperability that is the qualified references. It means, for example, that if you are describing that you have a data set, it's quite interesting that you can add information about, okay, this data set has been generated by, for example, this tool. Okay? Or this data set is another version of this other data set, etc. Okay, so all this information can help you to enrich the information you have for a specific resource. And when we talk about interoperability, we're always thinking about data, but we have to start thinking in another resources like will be software, tools, workflows, etc. Next slide, please. Okay, so this is the vision we can say of the EOS, the European Open Science Cloud. This architecture that you see right now probably will change in the future because they are working, as you know, in a new architecture based on the EOS nodes. Okay, but as you can see, one of the core parts of this European Open Science Cloud is the interoperability framework. Okay, that is basically allows you to move this data between the different communities, but not always between the different communities, also between the different services. Next slide, please. Okay. Thank you. So how it works, this EOS interoperability framework? Well, there are basically 4 different layers, okay? You can find the first one is the technical interoperability. So in this case, they have some barriers on recommendations about, well, if you want to use a specific service, you have an API, but you have to document this API, or you can access to this API following this specific protocol, like for example, HTTP. Okay? So this is basically the ground basis of the interoperability. But if we move to another layer, a more abstract layer, we can find the semantic artifacts. Okay, and these semantic artifacts will be very complex artifacts like ontologies, where you can express the entities and the relation between the different entities, but also schemas, specifications, and different control vocabularies. It means this is we can say the layer where resides the language that we are using, okay, to interact between the systems, okay? Then we have another layers like organizational interoperability and legal interoperability. Okay, the organizational is about the governance, how to interact with the different systems, the agreements between them, etc. And the legal, as you can imagine, is about the licenses, no? If I have, for example, a specific service that I have to use or interact with them, I need to know if I need a user, what are the resources that I can access, etc. Okay, so all this information are compiled in this EOS interoperability framework. So next slide, please. So what is exactly the role of the research object and error crate? As you can imagine, I just put some of the concepts that, well, if we need to operate information that has different nature, like data, software, etc., we need something that encapsulates all this information. So next slide, please. So according to the EOS interoperability framework, they use the term of digital objects to refer or to any kind of object that allow binding or critical information about any entity. Okay, and this digital object, as you can imagine, we can use the research object plus the specification of error crate to specify all this information around the digital objects. Okay, because it is not only important the information that there are inside of the object, for example, the data, but also the metadata. Now, we need to describe it. Not only this metadata about this specific object, also the relation of this digital object with another one. And ErrorCrate and ErrorHub is a very nice technology, and from the technological point of view and also from the conceptual point of view to make this interaction. So next slide, please. So what are the challenges that they face in Reliance and in Interoperable? First, we need to how to assess the fairness of our research object. And also, can we have a question about, well, we use this research object also to express the, we can say, the legal interoperability that we need. Next slide, please. So we're running on a study. We develop a tool called Pharos that is you can see because it's integrated in the AeroHub platform. So basically, the first question is how to measure the fairness of the research object. I have to say all the research object, remember that the research object is a composition of different digital objects that there are inside, okay? Data sets, software used in our research, etc. So we conclude that a good approach is, well, we can explore all the subcomponents, all the resources of this research object, plus the research object itself, okay? And for that, we use the tool Pharos that we develop in Reliance, together with another external tools that you can find there, like Fuji, FOOPS, etc. Okay, and finally, we aggregate all the results, okay, that we obtained in different metrics. Okay, these metrics were based on the FAIR principles in all the FAIR principles. So next slide, please. So I can show you some of the results that we get. Just highlight the part of the interoperability. Okay, so basically we analyze all the research objects that you can find in the platform AeroHub. As you remember, AeroHub use a JSON-LD file which represented knowledge. Okay, and remember that AeroCrate relies on schema.org. This is a popular vocabulary to describe resources on the website. Okay, and as you can see in the graph, they pass more all the metrics and all the tests that we design for interoperability. And what is the reason? Next slide, please. Well, Denise, the reason, the other one, sorry. No, the next one. Okay, no, it is not the slide. Sorry, just put the other one, the previous one. Yeah, perfect. This one. So the reason was that in this case, as you remember, and Stian said, and the error crate, you can find the different specification, not only of the error crate, but you can find metadata from the different digital objects. Okay. So there was some times that the digital object was not present in the AeroHub platform. So when we launch the tools to extract the information we need for the metrics, we cannot reach them, okay? Because they don't have a specific vocabulary or they don't follow some specific schema, etc. But what happened when we try with a research object? In the research object, this information was present in the error crate, okay? So we can access to the metadata that is not present, we can see in the original repositories, but we can access to this metadata using error crate. So next slide. So for this reason, we think that the error crate, using an specification like error crate to describe research objects, gives you a more realistic picture of the fairness of the digital object. Okay, it helps you to enrich the information that we have from a specific digital object that they are not present when you publish your digital object. Next slide. And to finalize, we will explore also the legal interoperability. So we launch an analysis, and we run an analysis with different schemas related with the legal domain. Okay, and one of the results, one of the specifications that we used was error crate, and in error crate we detect that next slide, please. That basically they have like two different attributes for specifying this legal interoperability, that is license and the right holder, copyright holder. The copyright holder is used because the entity of this data or this digital object will be different than the author. Okay, so one of our conclusion is, well, I think it's a very good starting point, but maybe we need more attributes in the future, in future specifications, okay, to allow the access control to the data, or even to describe the license, because one of the now is we can find, for example, the specification of ODRL, that basically where they are trying to specify the license, but in the machine readable format. So in this case, we need, if we want to communicate to, we can say, artificial systems, we need to properly describe the licenses, the control, who can access, etc. Okay, so I think this information in the future will be very interesting and very relevant for Rate. Thank you for your attention. Well, probably we will discuss later some of the points of the presentation.
Indeed. Thank you very much, Esteban. So you've heard about our crates, interoperability, etc. Now we will go into the practical use cases of them, and we will have two of them for you today. So first, we'll hear from Marie-Josse from Ifremer to talk about workflows in Galaxy.
Yes, hi. Hi, everyone. So I will talk about Galaxy and how you can use Workrate into Galaxy. So a bit of context about what is Galaxy. Galaxy is an open source platform. So this is what it looks like when you go into an instance of Galaxy. So on the left side, you have all the tools that are available to process your data. So tools are scripts that you can easily used to analyze your data. And on the right side, you have your history. So this is the part that will interest us today. From the history, you will have all the steps of your analysis with all the tools and data sets that you used and produced. And from this history, you'll be able to extract a workflow. And from this workflow, you will be able to have a Workrate. So next slide, please. The advantages of Workrate into Galaxy. So with Workrate into Galaxy, you can have the sustainability of workflows and the possibility to have them easily reproducible and interoperable from one platform to another of Galaxy to another. And besides, one of the main advantages is that Workrate is implemented within Galaxy cores, which means that when Galaxy is upgraded, Workrate keeps working. Then, next slide, please. We will see a bit more about an example of a workflow. So this is what a workflow looks like into Galaxy. You have all your steps with the different boxes here and your tools that are represented in these boxes. And on the right side, you have all the metadata and information that of your workflow. So for instance, the author, the license, and the description of it. Afterwards, you can run this workflow. Please, next slide. You can run this workflow, and once you run this workflow, you'll be getting all the analytical steps into your history that I shown you just earlier. And once you have done that, you can, next slide, please. You can then generate the Workrate from this history. So you are not exporting the workflow itself as a Workrate, but the analysis of that you run with this workflow. So once you've done that, you can generate this Workrate, and then multiple possibilities is offered to you. Next slide, please. One of these possibilities is to use this workflow with this Workrate on Workflow Hub registry. So it's a registry for describing, sharing, and publishing scientific computational workflows. So they achieve that through extensive use of open standards, including Workrate. Next slide, please. And it's really easy to just create a new workflow and upload it into Workflow Hub. So this is an example of how it looks like on the platform. You can just log in, then you can join a team. So for instance, the Galaxy team, and then you can create your own workflow by uploading your zip folder that you can see here in the middle of the screen. So this zip folder is actually what you get once you generated the Workrate from Galaxy. And then, next slide, please. You can directly have your workflow onto a Workflow Hub. So this is the workflow that I shown you on Galaxy. So it's a Marinomics identifying biosynthetic gene cluster. I will not go into the scientific details of this workflow, But as you can see here on the screen, you have all the different steps that are represented and all the different data on the bottom with the different annotation that I've made on the workflow in Galaxy that were rightfully transcribed to be on Workflow Hub thanks to the work rate. And one of the main advantages of that is that once you've got your work rate into a Workflow Hub, you can have the version of your workflow, which means that, for instance, here we have the version 1, and if I want to make a change, you will have the version 2, and you can go from one version to another. And for instance, if you are a random user and you want to use a workflow into Workflow Hub, you can go into Workflow Hub, search for the workflow that you're interested in. So for instance, this one. And you can see on the top here, you have the run on Galaxy. So if you go to the next slide, you can see that this run button allows you to directly redirect you to the Galaxy instance. And from there, you'll be able to run the workflow on Galaxy. So you'll be able to have all the steps, and you can choose the data set that you want to use as an input, either the same one that the original author did or another one that you want for your own analysis. So now that we've gone a bit about what's work rate and how you can use it into Galaxy and then use it into workflow and back into Galaxy, we will dive in a bit about, dive more in the work rate itself. If you go into the next slide, please, you can see that if we go back to our workflow, you have all these steps here. And if you will generate it as a work rate, as I told you earlier, you'll have a zip folder. So from this zip folder, you can dive into the different structure that is you can see here on the right of the screen. And what is interesting for us right now is the work rate metadata.json. So on the next slide, you have an example of how it looks like here. And then I will decorticate it a bit for you, some of the steps so of what it really looks like, and maybe a bit in the practical case what Stian showed us earlier in the theory. So in the next slide, you can see multiple annotations. So for instance, in the top of this work rate JSON, you can see an ID. That means that this document describes the directory where you're in. So in the big green box, you have all the tree structure of the folder that was shown just earlier. You can also see the creation time of the work rate, and you have all the details about the different data that were used by this workflow, but also produced by this workflow during the multiple tools. And so on the next slide, you can see the full tree structure of the folder. So with the different files, the dataset folder and what's in it, the workflows folder and what's in it. And you can also see, for instance, the license of the workflow. Then if we go a bit further down the work rate, you can see that we have the date of when the workflow was run and the different details about the datasets. So the first box is about the dataset that was used, the initial dataset that was used to run the workflow. Then in the second box, you have the different details about the dataset that was produced by the first tool, which is Findable. And in the third box, you can see the dataset produced by the second tool, regex find and replace. So this is about the dataset produced and not the tools itself, but you can guess which tools were used with the name and the IDs. So this is an example of a concrete work rate. And if we go back a bit into the tree structure, so into the folder itself on the next slide, you can see that into the datasets folder, you have all the datasets that you'll be needing to rerun the exact same workflow. And in the workflows folder, you have also the readable format by Galaxy. So if you want to complete the cycle, you can reuse this work rate by uploading either the .ga or the .yaml into the Galaxy instance. And you can also upload dataset, the initial dataset, and that way you can rerun the exact same analysis. But if you want, you can expand. You can see on the first picture on the top that you have expand to full form workflow. So if you do that, you can also choose to, from this workflow, change the initial parameters, and thus any user can do its own analysis from this workflow. And with that, you have a full cycle on how to use work rate and how it looks like. And on the next slide, we can see that we have some open opportunities and contribution that we can maybe add, because there are some things that can be ameliorate into the work rate functionality of Galaxy. So for instance, we can ameliorate the work rate profile that Stian introduced earlier, but also improve the documentation. So we already started on that so that any user can use work rate from Galaxy. And one of the things that I told you earlier also is that we have details on the data sets and not on the tools itself. So that's something that we can add to the work rate, and hope that we can achieve that through our work into ferries maybe. Indeed, we are building up our knowledge right now, and it's a work starting from scratch. And so thank you for listening. And this is a work done in collaboration with Galaxy Europe, the Galaxy training platform, and multiple EOSC projects like Aquinfra, Euroscience Gateway, and of course, ferries.
Excellent. Thank you very much, Marie. Next, we will hear from Marc Portier from Bilis, Belgium, on the data management use case. So, Marc, you may take it away.
Yes, I hope I'm audible. Okay,
yes,
we had some struggle with video here, so I hope it keeps up. But I'm also glad you guys can see that at least I shaved and put on my best dress for you. Anyway,
you're looking good.
Thank you. Maybe just as a quick intro, also because we just had a chat about on the chat there is a discussion on obviously on using autocrates for workflows, as you've just seen in the presentation by Marie-José. But there is kind of a distinct usage, equally important to my feeling, for using autocrates to package and hold the data management object, the data objects, the data products, the raw data, whatever, by themselves. And this is what my use case is pointing out, and is going to delve into EMBRC. The next slide, please, where we are involved in a project which is called IMOBON, which stands for European Marine Omics for Biodiversity Observation Network. And we are, well, on the map you see the involved partners. There's a number of stations that are doing, that are all committed to using the same procedures and methodologies, and doing sampling on a regular basis to discover some kind of a biodiversity mapping on whatever they find. And they are using gene sequencing and omics analysis for that. And the big idea is, and that is why it is a fitting use case for this story, is that the distributed data management that is in place for this project is based on GitHub and autocrates, and it's targeting linked open data publication. By the way, for the people that are knowledgeable to ferries, each time people are mentioning Pilot 5 or number 531 and with the name Marine Omics Observatory, that's actually the same people, and it's actually the same data we are talking about as now in IMOBON. Now, when we are talking about targeting a linked open data publication, next slide. So this 5-star semantic web publication of the data, now this is actually physically embodied by this little website. So the main goal of this whole data management I'm trying to go and explain to you is to produce this website and have this website work not only for humans, but also work in what we call linked open data or semantic web, or by applying a lot of knowledge graph technology, which is actually also, like Stian was saying, slightly hidden and made easier, but very much deep down in the fundamentals of AutoCrate. Next slide. So the ambition for me today is to explain this full picture on the right side, go through the model to explain you the model and the flow of or what is this project is about, then where and how the data is managed, and to end up in how that actually is published on the web in a linked open data way, and how that then finally can be consumed in a number of independent ways, including how we are targeting it in the Fairies testbed. Actually, I also have some extra slides at the end to explain a little bit more our motivation behind choosing AutoCrate, tying it back into this presentation today. Also, I have to slightly disclaim that everything we're doing here is 60% complete. So if you go into this website and you find any broken links, that's because we're still working on it, but the main vision is there and the strategy is should be visible. Now, the next slide is showing you how this model is looking like. So what happens is there's a number of stations. On these stations, people are having on regular dates what we call a sampling event. That sampling event is producing mainly a biosample, so it's actually a tube that gets frozen in. But there's also some additional data at the time of capturing that biosample. There will be temperature, salinity, etc., of the environment also captured. Now, that's the green area. We call that the sampling area. Next is the yellow and blue. There is a separate organization, one organization for this whole project that is contracted to do the DNA sequencing. So all these tubes are gathered in what we call batches. These batches are sent over to this company. They are running the sequencing, which is eventually producing these large files. The people knowledgeable with this would know about FASTA and FASTQ formats, which is basically a text file with only 4 letters, being the 4 letters representing the 4. I can't even know. I'm an engineer. I don't know what they stand for, but everybody knows that there are 4 letters in DNA sequence, and so these files are basically filled with that. And being so large, there is kind of this common platform on ENA, which is gathering all of those, right? So we are definitely also using that platform for storing those actual files. And then we're coming into the red zone, and the red zone is the analysis. So there's a number of experts in the consortium that are then downloading these ENA sequences and doing what they call an automated analysis using a workflow, and out comes a number of results. The name of that process is MetaGoFlow. For the people that are into this, this is kind of based on the Magnify workflow from EBI, but it's a custom configuration or setting that is really tuned to produce the results we want to have. And those results are mainly occurrences, like these are the species we found, but not only the occurrences, also something they call the functional analysis, which is actually, regardless of the species, we also identify which kind of enzymes are possibly in being produced by this DNA, and how they could be accounting for either food or poison for that could be present in that environment. So that's the big thing about the model and the flow of everything that goes about. Then how are we going to store all this information? Well, each of these colors, next slide please, you will find them coming back in the next layer of this graph, where each of these sensible units of work, I would call them, are being reflected in their own separate autocrates. And this is something we actually do. And this is one of the fun things about having these autocrates, is we can actually group the work depending on the kind of people or the flow that is involved, right? So not everybody has to be able to access and control all of the data. We can group this in a way that closely resembles the most natural way of working of the people involved. But in the end, we've not only identified these crates, we also organize them as different GitHub repositories on GitHub, right? And this combination of using Autocrate and GitHub allows us to do to include the metadata, but also have Git automatically track for changes and support a distributed manner of all team members to interact with this data. Not only that, by putting it up on GitHub, it allows us to associate a number of automated workflows to a technique which is called GitHub Actions, right? Then slightly introducing here this purple section, which is on the fourth thing on the right, which is sliding in from this analysis phase, is the fact that out of this analysis phase, again, a number of large files are coming. And some of those are not welcome on ENA. So we had to provide a known solution to store these, because the fact is that they're also very not welcome on GitHub. GitHub per repository limits the amount of space you can store there. And for that, we've taken the road to combine a project which is called dvc.org. In combination with S3, the very popular object storage. And what DVC is actually doing is it's on the person producing these large files. DVC will kind of push it up to S3 and replace your local file with a stub file. And the stub file only contains the pointers to the actual storage. And the stub file is what gets into GitHub and still follows all the rest of the automated flow and organization we are providing. Good. And then the next slide is how we are from this actually pushing this out on the web. And for that, again, we are abusing or using the features that are available on GitHub. And now we are employing a number of GitHub actions and are combining that with the feature GitHub pages, which is actually giving us a free HTTP publication of everything we are producing, right? And actually, the green, yellow, red you see now are the same recurring autocrates you saw before. And in those, there's largely three elements. There is, of course, the autocrate metadata JSON, which is in the middle, which is the metadata we can simply expose. Inside the autocrate specification wasn't really mentioned today yet. There is an opportunity. Well, there was a small demo from Stian on how you can visualize autocrates. Well, that's that part of the specification. And we also kind of take the opportunity of produce turtle files out of some of the data. So in the end, much of the data and the metadata are all traversable and exposed via this website. And on the right, you see there is a small web content management where we have the opportunity to create some static pages and some glue HTML that allows to do the navigation for end users. And then in the final slide of this big story, you see the many ways how this linked open data publication on the web can be consumed. So straight in the middle, of course, anybody with a browser can directly go to this website and explore what is out there. But we've also investing in a data analysis platform at VLIS, which we call KGAP. And that will allow you to harvest linked open data, not only from data Emobon, EMBRC, but you can link in information for instance, from ORCID or other linked open data publications like Marine Species, Marine Regions, marineinfo.org. Those are 3 important resources of linked open data. All of that can be assembled and harvested locally on a data analyst's laptop and be investigated and queried over there. But of course, within FAIRES, the whole idea is that the ID.DAS asset catalog will directly be able to consume the list of the catalog of autocrates, which is our metadata DCAT exposure, will be able to directly consume that, and as well the UDAL broker will be able to query into our system. Maybe we're still debating that on the right side by using a very tuned little local data lake service that would be indexing or making available some support for queries. So that's it. This is basically how we're building it up. Then my remaining slides are about our motivation for using AutoCrate. I think there's 2 technical ones before. Maybe next slide. Just explaining. Oh yeah, this is the preview stuff. People interested, you can follow that link. We have a small GitHub action people can reuse that will automatically produce this HTML view out of your AutoCrate. And the big idea, next slide, is that I think there's a pointer to the GitHub repository. Yeah, there on top. This is where you can find it. But the big idea is that out of your GitHub repository containing your AutoCrate, this will create your mini website that is linked open data aware. And similarly, we apply a lot more GitHub actions for automating a lot of stuff, right? For now, we're doing Google Docs imports. We're synchronizing metadata with ENA. We're doing QC checks on whatever is happening there. And we also include some semantic uplifting. So some of the CSV files, for instance, the downloads from Google, are automatically converted into triples that can be analyzed in a semantic way. Right? Next slide. Now I'm really going into my motivation. One of the big advantages we see in using AutoCrates here is that we no longer need to live under what we call central repository control. And I'm making it a little bit extra dramatic, but the way to look at it is that for a lot of data, putting something in the central repository is the first time that people think about the metadata. It's the first opportunity to add metadata, and it's often limited to what the central repository is designed for. So it's too late and too limited, right? And it's always lagging on innovation. And what I think is the benefit of going the AutoCrate way is that we're more in a get it while it's hot and a fix it at the source environment, in the sense that the expert is capable of expressing and extending the metadata he wants to add to his data, to their data, really locally there on the spot, right? And the repository can still, as it's doing now, harvest that information and decide which parts it's capable of understanding and putting into its search. But now you're actually reversing the control, because you don't have to wait for the repositories to say, oh, that was a good idea, now I'm going to add this kind of metadata. No. On the source, you already added the metadata. You can go for the innovation, and when the repositories catch up, or a dedicated repository for this domain emerges, they can adapt to whatever metadata is already provided on your environment. So you more get into an environment where there is an open discussion on what is successful and what is needing to be supported by the repositories, rather than we have to wait for the repositories to change their ways. Good. Next slide, another big reason for us was in the self-containment, right? So a really easy way for looking at these AutoCrates, there's a self-contained package. It has all the parts and all the remote parts, which is often referred to as the data entities, but it also includes all the descriptions, which are referred to as the contextual entities. And we slide on this web publication, which makes them addressable on the web, published like mini websites, and actually full-fledged members of a linked open data environment. Members of the semantic web, if you like, which we find very important. Then next slide is more on a meta level. The nice thing about this is that we have many crates, which allows us to have people keep their own work and their own vision very simple, right? You might be overwhelmed by my presentation and the complete complexity, but for each of the researchers involved, they are tuned to just a limited number of CSV files and the scope they are working in. And this is not unlike we see creating complexity through simple building blocks, either in Legos, but also on the web itself. Every website is a very simple thing. The complete web is overwhelming, and nobody could be able to envision designing that by themselves, right? And then the final thing I think I want to say about AutoCrate is about the atmosphere. Next slide. And the open style, which I think is kind of a really meta observation, that in my feeling, there is a way to recognize good design or good specifications. And one of the key things there is having lots of space within. What I mean is make simple things easy, make hard things possible, but allow to be expanded and used in a number of ways. And that's particularly what you see with AutoCrates. And it's also why you see this dual usage, both as a workflow packaging system, as a data management or a data packaging system. And there's other examples doing that. HTML, URL, many of the web standards do that. And you see that reflected in the AutoCrate design principles. Also, I really would welcome anyone. I didn't catch Stian mentioning the monthly community, but there is a very healthy community behind AutoCrate. You will be welcomed, even if you're there only temporarily for very specific things. But you will also see there this group carefully reflects on precisely these principles, not limiting other peoples to do anything they like to do, but also making sure that what you like to do doesn't get exposed on all the others. So there's that fine balance to be reached, which I particularly like. Good. People wanting to know why the teapot is there, I'll explain, but that's a really side story to this. I think this is my last slide, and I hope I didn't go too much over time, so we still have some time for Q&A.
All right, thank you very much. Yes, maybe, well, fortunately, a lot of the questions have been answered in the chat, but since we're already on the dot on the time, or a little bit after, I will give the chance if any of the participants have additional questions that haven't been asked yet, just to raise your hand or mark us in the chat, and then we will provide you the permission to speak. So far, I don't see any hands raised. Okay, well, meanwhile, while waiting to see if there are any further questions, I just want to promote our upcoming on-site event, which will be on the 10th of October in Naples at the Stazione Zoologica Anton Dorn. This is an open day basically for Fair Ease. So if you happen to find yourself in Naples around this time and you'd like to interact with us, please join us there. Now, there is a question from Paul Millar. What is the motivation for using signposting given that the availability of DCAT description? Is there anyone who would like to answer that?
Yeah, I can answer. You want to do it, Marc?
Go ahead.
All right. So signposting is what you need before you get to the DCAT description, right? So part of the problem we often find, particularly in traditional repositories, so you click on the DOI, you get a landing page. Where's the metadata? I need machine readable metadata. How do you even know which machine readable metadata is? How do you know if it's DCAT or AutoCrate or what is it? That's what the signposting provider makes those explicit, rather than you having to guess and content negotiate and hope for the best. So it's about lifting this up in the open. It's very non-intrusive, so it's very easy for people to add to existing repositories, like we did in Berkeley Hub, for instance.
Yeah. The way I explain it is also it's linking back. Typically, when you have a DOI and you come to a landing page, you have a metadata that shows you the link to the download URL. So then you get a PDF. But the machine, how does it ever get the link back? Well, that's where fair signposting comes in. If you have a direct link to the PDF, then in that link in the header, or well, it's in the header in that case, in the header, you will find a link back to the metadata. And think about how this could be used, right? If we would all start doing fair signposting, it would allow for, you know, everybody who is in academics knows that if you want to email somebody else about a publication, you should send them the PDF. You should send them the DOI, not the link to the PDF, right? But if somebody else would send you the link to the PDF and it has signposting, then we can envision a world where your browser picks up on this and says, hey, I know you're a researcher, you're downloading this PDF. Actually, this is the DOI of this. Do you want to know how to cite this, look into the metadata, et cetera, et cetera? This is the kind of automation or machine support we can expect if we not only have a forward link, but also a link back. That's basically why fair signposting is also used in our approach on data, immobile, EMBRC. You will find those headers in there as well. So.
Thank you. As follow-up statement, there might be an interesting conversation on this topic on fair signposting and some alternative approaches. Okay, so I think there are no other questions, and I don't see any other hands up. So I guess we can close here, but before I close, is there anything else maybe that our panelists would like to share? Maybe a last message from your side? If none, then I suppose we can close here. So just a reminder, the slides and the recording will be up within a week. So watch the website specifically. It will be in the event page. Thank you very much for joining us. And we do look forward to seeing you again in our next webinar. So thank you very much, and big hand to our panelists and our speakers for the information today. Thanks, everyone. Bye-bye.
Thank you, everyone.